In this video, I'm going to talk about Always Encrypted. If you have watched my beginning videos, I have explained what is Always Encrypted, and this has been introduced in SQL Server 2016. If you have watched my previous videos, I have explained how to encrypt the column and encrypt the database, backup, and etc. etc. Those are encryption features to encrypt the data at rest. Let me explain. You have application server and you have a database server. The previous videos what we have seen to encrypt the data in the database files. But how about, let's say user connects to the database application server, and application sends the sensitive information in the plain text to the database server. So you can still see the data here, right? Unencrypted data here. And even in the buffer pool, you can still see the data here. But here in the database files, it gets encrypted. You encrypt a column, you encrypt the database files, but finally the data is encrypted here. But what about here and here and here, right? So this is data in motion and this is data in rest. Always Encrypted is introduced in SQL Server 2016 to encrypt the data at rest and at motion. So what happens is you need to have the keys, a symmetric key or asymmetric key to encrypt the data, right? For example, in Always Encrypted, you use certificate to encrypt the data. But where is the certificate? Certificate is not stored in the database. Typically, if you encrypt the columns, TDE, or backup encryption, those, you have to use the certificates and asymmetric keys, whatever, right? Those things are stored inside the database. But in the Always Encrypted, you have the certificate in the application server. In the application server, you can have certificate in the certificate store, and your Java application or .NET application, whatever the application, it can use this certificate to encrypt the data and send the encrypted data to the database server, and then data will be written into the database files. So the data is encrypted here. So encrypted data travels to the database servers and all over the place, right? If you see the data here, encrypted. If you, everywhere it's encrypted except here. So whoever got access to the application server and those people who got access to the certificate, they can see the data. So it is not completely protected. If you implement Always Encrypted, DBS generally they will have access to the database server. They can do anything they want in the database server, right? Still DBS cannot see the data because data is encrypted here and it gets sent over to the database. So if DBS can take a look at the server where the data is always encrypted, right? But here, if you have access to application server, then probably if you have access to application server as a administrator access on the server, then probably you can use the certificate to see the encrypted data. But still, you can limit a lot of unauthorized access. You're safe in many ways, right? This is one encryption feature that Microsoft introduced in SQL Server 2016, because many SQL Server encryption features, column level, TDE, backup, there are so many features, hashing, Microsoft introduced. They are protecting the data here. But what about the data here? What about the data here, right? And what about the data here? So there are many areas still it is not protected. So this Always Encrypted covers many of the things, data in motion and data at rest. In Always Encrypted, this is what happens. You have the certificate here, and then the data gets encrypted here, right? So if you have another application server, let's say you have multiple application servers in the farm, you have clusters, you have load balancer, you got multiple application servers, then what you have to do, you have to copy the certificate that you created on this server to every server, to every application server. So this is a new application server, then you got to copy the certificate here, and then you can, this application server, the application here, it can use that certificate and then encrypt the data. That's how this Always Encrypted works. You don't specifically create the certificate, you have to create the column master key, column encryption key, and stuff like that, and that creates the certificate, there is no TSQL scripts fully implemented in TSQL scripts. You have to use a little bit of PowerShell, and then Management Studio. Management Studio, it can invoke some PowerShell scripts to implement the always encrypted functionality, the future for you. But so far what we have seen, column level encryption, TDE, all the encryption that we have seen, you can use TSQL to implement the encryption technology, right? Encryption features. But here in Always Encrypted, you have to create the certificate in Windows Certificate Store. You don't have a TSQL yet for that, okay? But to create the column master key and column encryption key, that gets stored in the database, the column master key and column encryption key. To create CMK and CEK, you have the TSQL statements, but to create the certificate, you don't have it. So I would say you can use Management Studio because that integrates with PowerShell to create all the things for you, certificates and blah blah blah. So right now you can use Management Studio or PowerShell to implement Always Encrypted. That's it. It encrypts the columns. You wanted to encrypt columns in the database. Okay, for example, SSN, credit card number. You wanted to encrypt certain columns in some tables, right? So then you can specify, I wanted to encrypt these columns. Then what it does, Always Encrypted future, it uses CEK, column encryption key, to encrypt the data. And there is a CMK, column master key, that encrypts this. And column master key, it depends on the certificate in the certificate store, which is stored in the application server. So in the column master key, if you browse the catalog views, then what it shows is where is the certificate. What CEK is pointing to, all that information will be stored in the catalog views in the database. So if a hacker just takes the data, he can see the column master key, column encryption key, but he cannot have access to the certificate here. Okay, so you got to protect this server. So when application user enters the data, it gets encrypted here, and you send the encrypted data here. If you want to decrypt, you get the decrypted data back to the application server. Here you decrypt the data. Every time you encrypt or decrypt, it happens application server. So you cannot use simply the database features. For example, you wanted to copy 1 million records from one table to other table. Okay, so you have a table, you have a couple of columns with encrypted. You have encrypted 2 columns in this table, and you wanted to copy this table to other table. You cannot simply say insert into this table, select star from this table to copy 1 million rows or 10 million rows or 1 billion rows. Simply it won't work, because this table you have to again you have to create proper metadata and stuff like that. So there are some utilities. You can use BCP to dump the data, and then you can again decrypt the data. But again, remember, if you want to decrypt or encrypt any time, you cannot use database engine future to do that, because it doesn't have that capability. Simply, you should know why certain things are not working. Basically you are trying to decrypt just using the database server. No, database server cannot do that. It has to send the data to the application server to decrypt. Anything you are trying to do certain type of things, simply it will throw an error. I can't do this. Okay, but from application server, you can write some .NET code or whatever, the VB script or any script at the application server to bring all the data, whatever the data that you wanted to copy, 1 million rows from source table to target table here, and then decrypt the data here, and then write the data into this table, right? You can do that. The encryption decryption is happening here, which is fine. If you think logically, anytime that you are trying to perform certain operations that are not right, that database engine cannot do, bulk operations or mass copy, there are many other things that you cannot do. Data has to go back to the application server for decryption or encryption. So you got to remember that. So we are going to look at some examples how to copy encrypted data from one table to other table, and how to use export import tasks in Management Studio. You remember, export task in the Management Studio, it gets the data from database server and store it in the whatever the Management Studio that you're running on. For example, from laptop you are executing the export task, right? From one server to other server. What it does, it gets all the data in here on your laptop, and then from here it pushes the data into the server. Okay, it doesn't push from directly from here to here, because you are bringing the data from database to the server where you can decrypt the data using the certificate. It's possible, you can do that. So management feature, I can show you that it works. And also BCP to decrypt certain data using the column encryption key. There are a few things I will show you how to copy encrypted table into non-encrypted table and encrypted table to another encrypted table. So okay, but there are many things that simply don't work. That is what always encrypted. So you need to remember, this is the key that encrypts the data, and CMK encrypts the CEK, and CMK, it depends on the certificate in the application store. That's it. I have some scripts here. Let's copy the script. Let's say this is my application server and this is my database server. I'm going to create the database on this server, but my certificate will be here. So let's connect to source server and create the database on the source server. So you can see here I have connected to Windows WinSource server from the target server. Right now I am on target server and I have connected to WinSource server. So let's create the database and use the database. I just created the database AE, always encrypted, and then let's create the table in the database. Okay, so I created the table, and then let's insert few rows. Let's select the table. You can see these are the records I have inserted. Okay, now I'm going to encrypt this column and this column. To use the always encrypted, we have to do this. We can see here encrypt columns, we can use this link, or you can say there is encrypt columns here. You can use this or that, either way it works fine. All right, I wanted to encrypt these two columns and then select deterministic or randomized. Basically what this deterministic randomized, it means if you are encrypting this value FE003 and you get some encrypted value, right? Let's say it is 1111. This is the encrypted data for this value. And anytime you encrypt this value, if it is deterministic, then it is going to generate same encrypted data 1111 all the time. Okay, so you can copy, for example, you can take that encrypted data and put it to this guy. You can copy and paste it on for the James. So James will have the same bank balance, whatever the clerk has. So basically you can create some indexes on this encrypted employee number if it is deterministic, because it is going to do some sorting. The value is going to be the same, the random number, the generated value. But if I say randomized value, then encrypted data, encrypted value will be a random number. So now if you encrypt, if I select the employee number as randomized, and if I encrypt this FE003, then it generates this value. And next second, if I encrypt the same value to another customer, then what happens? It generates different number. So every time it creates a random value, encrypted value, even though it's for same text. Okay, that's what deterministic and randomized. So here it shows CEK auto one. That first you have to create the column master key and then column encryption key. So this column is based on this column encryption key. The next screen, I can't change the value here. I have to accept whatever the default CEK auto one, because this is automatically generated by the GUI. But if you can change, if you wanted some meaningful names, you have to use this option. You got to go to the first you have to create the column master key and then enter whatever the column master key you want, and then create the column encryption key. Okay, so if you are creating column encryption key from this option, you can specify whatever the column encryption key you want, right? But if you are creating the always encrypted, the column encryption key through this GUI, this whatever I'm showing you, you have no option. You have to accept whatever it is. Okay, so click next, and column encryption key is based on column master key, and you don't have option to specify what is a name for column master key. It is going to generate some random name, CMK auto 1 or some, I don't know, whatever name it is. And then where you wanted to store the certificate, right? The column master key, it creates a certificate either in Windows Store or Azure Key Vault. These are the two options it stores. It shows. And then if you are storing in Windows Certificate Store, then probably the only option it shows is current user. Click next, and then proceed to finish now. That's it. It is, if you wanted to generate the PowerShell, you can run the PowerShell in PowerShell window, but the management studio is going to run the PowerShell window for you. If you select this option, click next, these are the things that it's going to do. Basically, it is going to encrypt these two columns, and these two columns, depends on CEK auto 1. Okay, this column employee number in this table is going to use this encryption key, and it is deterministic. And this column in the same table, employee details, is going to use the same encryption key, but it's randomized. So this is the column encryption key, and this is the column master key. You don't have option to specify your own name. And the certificate is stored in the current user, right? And the source database server is win source, but we are executing this on the win target, the target server. I think it is a application server. Okay, now let's click finish. All right, it just finished. Basically what it did is it created the certificate in the certificate store, and it created the column master key, and then whatever the column encryption key, and then it encrypted the existing rows. If you have millions of rows, it's going to take a really long time. Okay, you have to just leave this window open to encrypt all the data. Basically what it's doing is it is bringing all the data from the database server into the application server wherever you are executing this management studio, and then encrypt, and then sends the encrypted data back to the database server and update the value. So the data will be going back and forth between the application server for the encryption. All right, so we just encrypted the two columns. Now you can see, if you just execute this statement again, now you will see these columns, employee number and date of birth, they are encrypted. How do you decrypt? You can see it created these two keys. Can you rename? No, you can't rename, but you can create a new encryption key if you want. All right, so how do you decrypt this value? What you have to do, okay, let's take a look at the certificate store. You need to see where the certificate is stored, right? So if you, this is where the certificate is stored. Let's take a look at the catalog tables. So, okay, in order to see the data, for example, right now you can't see the data. You have to enable the special option while connecting to the database. Column encryption setting is enabled. Let's say I open a new query. I'm going to change the connection to the Windows source, and then specify this option and connect. And if I execute the same query in this window, it is going to show the encrypted value. But if in this window, if I execute, it is going to show, are you going to use parameterization for the queries? Of course, yes, enable. It is going to enable the parameterization in one of the options. So if you look at options, somewhere you will see, let's take a look at where is that option. You can see that enable parameterization for always encrypted. I clicked the enable button just before. So what it did, it enabled this option. Basically, this option enables to use the parameterization of the queries to see the always encrypted columns. I just want to show you that. Now, if you see, if I execute this query, I can see the columns here. So what it does is this management studio, which is using this certificate is stored where? On the Win target server. It brings the encrypted value from the database and then uses the certificate, and then it decrypts the values in the result set, and finally it shows the decrypted value to you. That's what it's happening here. Let's see if I have the certificate in this server. This is the database server. Do I have certificate here? No, I don't have any certificate here. I created the certificate here because this is where I have driven the always encryption wizard, right? I started that wizard. That's where it creates a certificate. If I wanted to execute queries from the database server, I need to have certificate in this server, in the database server. Not only in database, any server. Let's say if you want to execute queries from this server, this is another application server, or this might be your laptop. Then what you got to do, you got to copy this certificate from this certificate store into this server, and then open the management studio or SQL CMD, whatever the client tool, and then enable the encryption option and then execute the query. It works, right? So now let's take a backup of this certificate. So I can say export this certificate. Yes, export the private key, important, right? Include all the certificates and then click next. Password. And then the file name is okay, I just exported. This is that certificate. Copy the certificate to the source server, Windows source server or temp directory. Okay, now let's go to the source server. Go to the temp directory. I have this certificate. Right now, let's import that certificate. Click next and select the so the import is successful. I can see the certificate here. I copied the certificate to Windows source. Now I can connect to change connection. Go to the options. Do I still have? Okay, now let's copy this, and then of course the first time it's going to show you in the management studio. You want to enable that parameterization of the queries when you are executing in always encrypted mode. Say enable, and then it is going to show the details for you. So this is how it is. For example, this window doesn't have it because I created these windows for the earlier demos. Okay, so if I execute this query from here, I'm going to see this. If I open a new query, what happens? It will have, it depends on where you so for example, if I open, so here I execute this, I see that because from this query window I have that always encryption enable equal to true, right? Whatever the option, additional options I have given in the connection string. Then if I open a new query and execute, I'm going to see the data here. From here I don't have that option. That's why it is showing the encrypted data. So if I open a new query, encrypt data. So it's going to basically take the whatever the options that you have in this query window, it is going to use the same options if you open a new query window. Sometimes you might wonder what is going on, how it is enabling. So based on where you are starting the session, that matters. All right, so anytime you open a new query, you got to make sure do you really want to enable the always encrypted. But you can have that option enabled all the time because sometimes if the table is always encrypted, you may want to see the data, right? If it is not, then it's not going to do anything. So that's what it is. We have seen how to see the encrypted data. And if you are using SQL CMD, you can use option -G. If you are using this option from the management studio. If you are using SQL CMD, you got to pass -G. For example, SQL CMD -G. If you don't specify -G, then right. So if I execute this, I see the value here, but I see the encrypted data, right? So -G, I can see the value. So basically, this is what it is. This is what you need to pass. If you are using the connection string in your Java application and whatever the application that uses the JDBC connection, you have to pass this additional parameter in the connection string to see the encrypted data that has been encrypted by Always Encrypted. So now let's insert some records. You will know what is going on. If I select, I can see the data, right? I cannot insert. So it says you are trying to insert varchar into the var binary columns because see, when you encrypt the columns using always encrypted, it converts the column varchar into var binary because encrypted data can only be on var binary. So it is going to change the collation for the columns. I forgot to tell you, when I was driving that wizard. So when you are driving that wizard, it is going to convert the collation for the columns. First name, if you are encrypting the first name column and it has varchar 50 or 30, whatever it is, and it is going to change the collation to var binary because the encrypted data, it has to be in the case sensitive binary format. It cannot be case insensitive, accent sensitive, stuff like that. Basically what you're trying to do is inserting a plain text into the var binary. That's why it is complaining, we cannot directly insert like this. So you have to use some parameterized options to insert the values into the table. So what you got to do, see this value we have enabled already. We have clicked that button enable option, right? So that enabled this option. So if you didn't click that, then you got to manually go to this specific option and select this enable parameterization. Basically you have to use parameters. You cannot insert like this, you have to insert like this. So basically you have to define some parameters and pass that parameters instead of straight values. So then what it does is, when you execute query like this, first it executes a query and it asks database server, are there any columns that are encrypted? Then if it is encrypted, what is the column encryption key, what is the column master key, where is the certificate, etc., etc. It queries, and then it takes a certificate and then it converts this value into var binary and then sends that var binary. It encrypts this data into var binary, changes values into binary columns, and then inserts the data into the database server. That's what happens. If you want to insert the record, just enable the profiler. You see what is going on. This is how you insert. You cannot simply insert static values like this. So if I insert, this is how I insert. Let's execute this. Now it inserted, right? It's showing that rows are inserted. So if I execute the query, the fourth row I inserted. So basically I inserted the same values as here. We can see that here, right? This is what the parameterization means. Okay, so I just wanted to show you one thing. I'm going to another window. If I execute this, see, I have specified deterministic for this column, randomized for this column. So these two rows are same, right? So these two values should have same encrypted value because I selected deterministic option, right? So if you see, these two options are same. But if you see this one, they are different. The values are random, right? So that's what it happens. And then there are certain other things I wanted to show you. Okay, let's copy this script. This is something interesting. I'm going to search this record date of birth using this option randomized column, right? Date of birth is a randomized column, encrypted column. So if I select like this, it won't work. But this is a employee number. It's a deterministic. Okay, so if I execute like this, it works. Here, the row 3, for example, if you let's select all the rows, row 3 and 4 are same. So what I'm doing, this update statement, I'm copying this data, but I'm copying here and I'm pasting. Okay, I'm going to copy second record to fourth record, the date of birth and then the employee number. I'm going to copy the second record onto the fourth record. That's what I'm doing here, the two updates. And then now select the details. Now you can see. So without knowing, I don't know what is the value there, but I just simply overlaid with one information with other information. Okay, so I just want to show you it works. So these are some of the catalog views that you may have to remember. For example, so this is column master key and then modify date, and where is this column master key? Okay, it is in this path. All right, and then this is the CEK. Column master key is 2 and the column encryption key is 1. This is how it links. These two are linked. I said sys columns where object ID equal to employee details. So show me the columns in this table. So if you see, this column is encrypted and this column is encrypted. So if you go somewhere, you will see, okay, this is deterministic. This is how you identified which columns are encrypted or not. All right, that is one thing. Now this is something interesting you wanted to know. Copy encrypted table to non-encrypted table. So how you copy encrypted table to non-encrypted table? So you got to use export wizard. For example, this is one way of copying encrypted to non-encrypted. Okay, so basically what you have to do is you have to bring the data from the database server into the place where you have the certificate, for example, application server, and then decrypt the data in the application server, and then push the decrypted data into the target table. That's what you need to do. That's what the export import wizard does, right? Now let's do that. Okay, let's do this. Export data. You select this option. You specify column encryption setting as a true, integrated security because you wanted to use Windows authentication to connect. Your encrypted data is in the source server, so you have to specify your source server, which is WinSource. Catalog is AE, and then you have to enable this option because without specifying this option, it's not going to retrieve the any encryption data. Integrated security is true. Click next. And the target server, you don't need to specify this option, this driver. You can specify. Okay, let's say select Win target. We got the database on the Win target as well, right? So you have the backup encryption. This. Let's create the table. on the target server. Okay, I got the target table in backup encryption database in the Win target server. So here I select Win target as my destination server, select backup encryption, this one, employee details, and then edit the mappings. Employee details, it's already there. Why it is showing? Let's see. Okay, let's cancel this wizard and come back again. Okay, I don't know why it is showing. Employee details is there here. Oh, sorry, I think I created employee details in. Let's execute. Employee details, backup encryption. Oh, I am creating in the source server. Sorry, got to select the target server and then backup encryption and then create it. Now I can see the employee details here. So okay, so now it shows the details properly. All right, sorry for back and forth. So now I am going to export the data. So now I have transferred 4 rows from source to target. So if I go to target database, here is what I got all the decrypted data here. So that's how I copy the encrypted table from one database to unencrypted table on another database. Okay, so this is how I do. And if you wanted to copy encrypted table as it is from source database to target database, you have to use BCP actually. You have to BCP out the data. You have to use the binary format as it is, and then copy that binary format on the target server. Okay, so here in this example, I'm going to copy encrypted data as it is from one server to other server. For example, let's delete this table on the target server, and let's drop this table as well. And let's say script this table, put it in clipboard, go here. Okay, so you can see here, this is the script that it generated, and I can't run this script because I need to have the CEK and CMK on this server. So what I can do is, okay, we got the Win security, Win source here. All right, we got the column master key. Let's script out this column master key and then script out the column encryption key. So you script out these two encryption keys and then run it on the target server. Okay, I created the CMK and CEK on target database. Okay, so if I go here, always encrypted key, I have the keys. Now I have the keys ready to create the database. So if I create the database now, sorry, if we create the table now, it's going to create because it has necessary keys, right? So I have created the encrypted table as it is on the target server. These two are encrypted columns. Okay, so now my goal is to copy the data from the source server to target server. To do that, I have to use the BCP option. There is, of course, you can use .NET application. If you know .NET, you can write some .NET code to bring the data from database server. You can encrypt and then push the database. You can do that with .NET. But as a DBA, you have to use the BCP. For example, you have to run these commands. You have to create a login. You don't need to create a login. You can use the existing login and then enable this option for that login. For example, you wanted to use BCP using this user, you can do that. So this is how you do it. First, you have to use the BCP to get the data into a file, and then you got to BCP to bring the data from the file into the table. Okay, very simple. You first BCP out from here into the flat file, and then push the data from flat file into the target database. While pushing the data, you have to use this login. You can use any login for that matter. You can use your own login, but you have to enable this option while pushing the data from the flat file, the BCP file, into the table. So in this example, I have created a separate login and I have given this option for that login. And while I am BCPing in, I have specified this login. Okay, so that's what it is. So let's create this login on the target server. So let's go to the target server, and then I have to use EAE. This is the database I wanted to create the user, right? So I'm not going to create the login for that user. I'm just going to create the user without the login. This example says with login. Okay, that is fine. Either way, it's fine. So let's execute this. And let's see, a login is created. Bulk copy. Oh, okay, I created in Always Encrypted database. Where is it? Source. Sorry, not source. I have to execute this on the target. Sorry for the confusion. This has to be backup encryption database. So I create this here. Now I have the login here, bulk copy. Okay, so this bulk copy has that permissions, whatever whatever this permission. Okay, so I'm going to use this login to BCP into this database, sorry, into the table. Now I need to BCP out, sorry, yeah, BCP out from the source table. So let's create a format first. You have to create the format. Let's see where it created the format. It created the format under users. Okay, let's do this. So let's create the format under C temp. So now I have the format, BCP format, and then let's BCP the table, export the table. Okay, so here I got to use C drive. Okay, this is the data. And then now my next step is I got to use this, but before that I have to copy this data and the format, BCP format and BCP output. So cut and paste it in, paste it here. Now I'm using this format and this is my data file. This is the login I'm using to copy into the table. Okay, so very simple. It says login failed, cannot open the database. So what's the problem? Okay, I use the different table name. So I think backup encryption. So it copied 4 rows. Okay, so now I copied the 4 rows. Now let's execute. Let's connect to the target server. Backup encryption. This is encrypted. So now let's change the connection. Put this option. Now I can encrypt. So this is how I can copy the encrypted table from one server to other server as it is. So I have copied the encrypted table as it is on the target server, and I have created the encryption column encryption key, column master key, and I have put the certificate here on the server where I am executing this query. Wherever you are going to browse, you need to have the certificate there. If you are using the application server to query the data or laptop, then you have to have the certificate there. Okay, this is how you copy the encrypted data into encrypted table on the target server. And then you have seen how to copy encrypted table to non-encrypted table using the export task. And finally, we will see how to rotate the keys. You have to rotate the keys frequently, every 30 days or 60 days, whatever the frequency. Okay, the rotating keys means you delete, you change the certificate. You don't want to use the same certificate. So what you have to do, you have to use a new certificate. Let's copy this code, for example, and go to the source server. So here you have test database, right? In the test database, do we still have keys? Yeah, we have the keys, right? These keys are dependent on the certificates. So the test symmetric key is based on the test certificate. So let's execute this. Okay, hold on, go back. So here what I'm going to do now, test symmetric key. This is the key that I used to encrypt the data, and this symmetric key is using test certificate. Now I wanted to create a new certificate and use that new certificate for the test symmetric key. Okay, so what I'm going to do is I'm going to create a new test certificate uh, in the test database, and then alter the symmetric key to encrypt by new certificate. Okay, so if I execute this, then what happens is, okay, you got to open the test certificate key here. Okay, probably I'll copy this statement. Okay, so you open the certificate and then alter the certificate. So now if you run this catalog views, then it shows it is 256, right? 256 is encrypted by two certificates here. You can see that. Okay, it is encrypted by test symmetric is encrypted by test set and new test set. Now let's drop the old one. Okay, we dropped it. And then if you re-execute this statement, now the 256 is using this certificate. So that's how you rotate the keys to use a different certificate. And for TDE, you have to same thing. You have to create a different certificate and then use the database encryption key to use that certificate. That's how you rotate. When you encrypt the symmetric key or database encryption key with a new certificate, at that time before we rotate, it will be encrypted with two certificates. So you can use either certificate to encrypt the data, but when you delete, then you have to use the new one. So that's how you rotate the keys actually. You create a new one and make sure you alter the appropriate the keys below it, and then safely you drop the old ones.